Is it possible to predict the future using the laws of physics? I mean, let's say we have a tennis ball machine that shoots a ball at a specific velocity and angle. With this info, we can predict its exact path using Newton's laws. To make this prediction, we just need to know its initial condition and a set of scientific laws. So just like we predicted the ball's future, people thought there existed an ultimate scientific law which can predict everything that would happen in the universe if we knew the initial condition of the universe. This idea of a universe where everything is predetermined is called a deterministic universe. But in order to know the initial condition of the universe, we have to know the initial condition of the fundamental building blocks of the universe, called elementary particles. But the problem is, in the quantum world, things start behaving a lot weird. Elementary particles, like electrons, randomly change their positions and velocities. So there is always some uncertainty when we try to measure a particle's position and momentum. It's as if nature imposes a limit on our ability to measure a particle's state. This limit is known as the Heisenberg uncertainty principle, first devised by Werner Heisenberg. The uncertainty principle states that if you precisely know a particle's position, then there is more uncertainty in its momentum, and vice versa. To understand this, let's take a water balloon which has height and breadth. If the height is the uncertainty in position, then the breadth is that in momentum. When I try to reduce the height, the uncertainty in position, I inevitably increase the uncertainty in momentum, and vice versa. But what exactly causes this uncertainty? Well, in quantum physics, everything in the universe behaves both like a particle and a wave at the same time. This is known as wave-particle duality. While a particle has a single definite position, a wave doesn't. It is simply spread out everywhere. The question of where doesn't make any sense, but it has a measurable wavelength, which is the distance between two crests or troughs. Since all objects behave like a wave, they have a wavelength which is directly related to its momentum, given by this equation. The Planck constant is just a tiny number. A plane wave has a single constant wavelength, but it extends infinitely. Here we can know its momentum precisely, but its position is spread out over the entire universe. Now, this wave can't possibly describe an electron because we know it doesn't exist everywhere, so we add many plane waves of different wavelengths. The waves interfere with each other and form a more localized wave called a wave packet. In this wave, the uncertainty in position is smaller as the particle is found within this region. But the wave packet itself is a combination of many waves of different wavelengths. Thus, the uncertainty in momentum has increased. The uncertainty principle is a fundamental property of the universe, so no matter how accurate our measuring instruments become, the Heisenberg uncertainty principle remains as a fundamental limit to our knowledge of the universe. So sadly, we can't predict future events exactly if we can't even measure the present state of the universe precisely.